Let's go ahead and get started. So welcome to the SIG Service Catalog Deep Dive session. My name is Jonathan Berkhahn. I work for IBM as a full-time contributor to the Service Catalog project. My erstwhile colleague, Doug Davis, who is trying to escape, is also a contributor. He's one of the co-chairs. He gave the intro session yesterday. So this is going to be a bit more in-depth. So let's go ahead and get started. This direction. Okay, so what am I going to be talking about today? I'm going to start off with a quick overview of the Open Service Broker API. So this is what Service Catalog is an implementation of. We went over it briefly yesterday, but I'm going to go a little bit more in depth and just sort of recap things if you weren't here yesterday. Then I'm going to talk a little bit about the architecture of Service Catalog itself, what it physically is, how it plugs into your Kubernetes, how it talks to the service brokers through OSBAPI, the OSB API. And then I'm going to go over some of the design challenges we have faced and continue to face in our development of implementing Service Catalog. I'm going to go over some of the recent features we as a SIG have implemented, and then I'm going to go over our future plans, what we hope to accomplish in the next 6 months sort of thing. And then we'll have time for questions. So OSBAPI, what is that? Okay, so the Open Service Broker API is an open source API specification for the automated deployment, management, and use of services. And I'm using service in a very generic sense, not the specific Kubernetes service meaning, but more of a generic program that runs somewhere and is accessible on somewhere on your network. So pretty much, and it can be pretty much anything. The archetypal example we use is sort of a relational database. That's something that cloud native apps usually need. They need somewhere to keep their stuff because they're stateless. And that's a good fit for the OSB API model. But it can be pretty much anything. And we want to solve the problem of app developers shouldn't have to care about this stuff. They should focus on developing their app, not how do they manage their database. How do they hook up their app to a message queue? They shouldn't have to care about any of that. So it's an API, so it has two sides, the client side and the server side. The client side we implement as Service Catalog. The server side is implemented many times in various service brokers, that's what they're called. And they have three main endpoints that I'm going to care about for the purposes of this talk. They have a catalog endpoint, which you get, which returns the lists of all the services offered by the broker. They have an endpoint to provision, give me an instance of this specific service. And then they have a bind endpoint, which is now that I've provisioned this instance of a service, give me the credentials to access it. So that's the thing that we actually implement. And we translated this Open Service Broker API into 5 Kubernetes resource types, more or less. So Service Broker, Service Class, Service Plan, Service Instance, and Service Binding. So Service Broker is our internal representation of a broker that has been registered with a cluster. It has one or more service classes, which is a category of services offered by that broker, for instance, MySQL databases. Each class can have one or more plans, which is sort of a quality of service level of that class. For instance, in this MySQL database class, we could have multiple plans, which could be database sizes. So you could get 10 megabyte, 100 megabyte, 1 gig database out of that class. When you create an instance, it's a specific permutation of a class and plan. So of MySQL databases and of 100 megabyte MySQL databases, create me one of those. Create me Jonathan's 100 megabyte MySQL database. And then that instance can have one or more bindings created for it, which represents a single set of credentials to access it. So once I have my database provisioned through Service Catalog, I can create a binding that will give me a set of credentials in the form of a Kubernetes secret, which I can then plug into my running application to access that database. The magic. So we're going to briefly go over what Service Catalog actually does for you in terms of those abstractions. So here we have our friendly user and their Kubernetes. Now, once at the very beginning, you're going to need to register the broker with your Kubernetes Service Catalog. So this is sort of an operator level action, and you do it once, and then you don't need to worry about it ever again. So if this isn't under the domain of your normal user, they aren't going to be doing this. But if this is something that needs to happen, so you register the service broker, Service Catalog is going to reach out, hit that broker's catalog endpoint, and retrieve the catalog of services that it offers. And it's going to keep that locally and keep track of that. So that could be, how many databases this broker offers, what classes and plans they have representing those, so on and so forth. And then the user later on can go and look at Service Catalog, hit its endpoints, say, get service classes, what kind of things do you offer? And when that user figures out, they're like, okay, I want a database, this specific class, this specific plan. They're going to say, Service Catalog, create me a new service instance. And then the Service Catalog is going to go and it's going to issue a request to the broker saying, provision me a service instance with these specific class and plan. It's going to go and tell the broker that. The broker is going to do whatever the broker does to provision new instances. This is sort of out of the purview of Service Catalog. We don't have to care if it's banging rocks together or provisioning a VM or a container. We don't care. It returns to us, yeah, it's been created. The user then is going to go and deploy their application in Kubernetes, run a pod somewhere. And then in order to give access to that application to this instance, it's going to have to create a binding. So it's going to say, Service Catalog, create me a service binding. Service Catalog is going to be like, okay, I'm going to go and tell the broker to do that. And it's going to return to me some set of credentials, usually a username, a URL, and a password, but it could be pretty much anything. But that's usually what it is. And Service Catalog is going to stick that in a Kubernetes Secret for you. Now, Kubernetes Secrets are already used outside of Service Catalog to manage access to services and other things. So hopefully most Kubernetes users should be familiar with that. And then they're going to have to go ahead and manually attach that to their app. So they're going to have to kubectl edit their application declaration somehow, give it access to that secret, and then their application can use the information contained in that secret to go and access the service instance wherever it is, whatever it is, wherever it's running. So this is sort of the basic life cycle of using Service Catalog to provision and access services. So now I'm going to briefly talk some of the issues we've encountered and continue to encounter as a Kubernetes extension project. So Service Catalog, in terms of Kubernetes incubator projects, is one of the oldest. We've been around for about 1.5 years, 2 years now, which means that many of the new and exciting features that exist in Kubernetes today didn't exist when we started the project, so we had to sort of break new ground ourselves. For instance, custom resource definitions didn't exist when we started, so we had to pretty much come up with our own solution to that problem. TPRs, the predecessor to CRDs, did exist, but they were pretty buggy and very new, so we didn't really want to stake the stability of our project on those. So we decided to come up with our own solution, which was API aggregation. For various reasons, we didn't want to have Service Catalog have access to the main etcd store for Kubernetes proper. So our solution was to provision our own etcd instance, run an API server and controller on top of it, and use API aggregation to hook that API server into the main access point for the main Kubernetes API server. So when the main API server receives a request to manipulate one of our resources, it proxies that off to our API server and we handle it. From the user's perspective, this is completely seamless. They can say kubectl create a service broker or a service instance like any other type in Kubernetes, and it's gonna end up at our API server so they can manipulate these resources the way they would any other Kubernetes resources. Another issue we faced is that Kubernetes names of objects are fixed. They are immutable. However, we have outside information that we need to keep track of, the various names and GUIDs of all these broker resources. And the OSB API resources have mutable names. They are allowed to change. They're allowed to be updated. And they also have GUIDs that are associated with each of these resources, and those are fixed and immutable. So we need to keep track of both of these, and some of these are more or less human readable as the case may be. So in our various resource types, we implemented in the spec, we have a whole bunch of external fields that we use to keep track of these. And they're sort of translated back into the metadata names and UIDs that the user normally interacts with. So the external name, that's sort of what we use to keep track of the various resources from a user's perspective. MySQL database, my MySQL database, 100 megabyte MySQL database. However, the actual names of the resources we pull from the external GUIDs that are present in OSBAPI, which sometimes aren't exactly human readable. So we implemented in our CLI tool SVCat, which I'll talk about in a minute. We generally keep track of things via their external names rather than their Kubernetes metadata name itself. Another issue, this is more of an ongoing issue that we struggle with, is broker synchronization. So Kubernetes sort of considers itself to be the source of truth of the universe. It allows users to declaratively modify state in the etcd with the expectation that somewhere down the line, I will be able to reconcile that with reality. Which is kind of a problem when, in order to do that, we need to make a call to an external system, in our case, the service broker, which could say no. If the user deletes a service instance and we tell the broker, hey, I deleted the service instance, and for whatever reason it says, no, you're not allowed to do that right now, that's sort of a problem because the etcd resource has already been marked with a delete flag. It's basically already gone or going to be gone in the very near future, which can make it hard to reconcile these changes. We've fixed some of these in the past. Like I said, this is still an ongoing source of contention between us and the broker, and it also, this is a problem for other platforms that implement the OSB API, so this is also ongoing in terms of changing the spec to make this a little bit easier. Okay, so moving right along, some recent features we've implemented in the past 6 months. So originally, the original IMPS resource types that we implemented pretty much allowed cluster-wide access to anything that was on the service catalog. And we've received a lot of requests for various ways to want to filter that. And we've sort of implemented a couple of generic solutions to that hopefully should allow cluster operators and cluster users to restrict access in a way that they want. The two I'm going to talk about today are namespace service brokers and catalog restrictions. So what is a namespace service broker? So this is how the original service brokers worked. You have your Kubernetes cluster, and in our example here, we have 2 service brokers registered with them. Each of them offers a single service. So this service broker is available cluster-wide. So any service it has is going to be available to all of your users, regardless of any namespace privileges they do or do not have. The same is true for service B here. Anybody can see it. This can be a problem for a variety of reasons. The 2 main ones are, obviously, if we have a service that we only want specific users to have access to, this doesn't allow for that. The other issue, which is maybe a little bit more subtle, is that because this is sort of a wide-changing, cluster-wide operation, generally we only would allow cluster operators, admins, the ability to register brokers with the platform, which is good if you're a cluster operator, but maybe less good if you're just a regular user and you have this service broker and you want to bring it with you and use the services it offers just for yourself. So our solution to this was to implement namespace service brokers, a namespaced version of the service broker resource that registers with the cluster just like a normal service broker, but it and its children resources are only available in a specific namespace. So in this case, we only register each of these service brokers in the single namespace, and only users that have access to that namespace can see and use its resources. So this, like I said, also it solves the problem of visibility, access control to these services. But because each of these brokers is only visible, it only modifies the state of existence of the namespace that it's been added to, this is also a far less destructive operation. There's no chance of, I want to add my specific service broker and it has a name collision with something that's already present on the cluster-wide level. So it's a lot safer to allow normal like app developer users the capability to add and remove these from the clusters. So they don't need to go bother an admin to add their favorite little service broker to get access to their resources. This is something they can do themselves, spin it up, use it, break it down. Nobody has to care. Name catalog restrictions is sort of our name for a couple different things we implemented that basically allow the white and black listing of services on a specific service broker. So when you create the broker at register time, you can specify a catalog restriction which is basically either a white or black list of the services that belong to that specific broker. So this is a simple example of a blacklist. When you create the broker, specify a catalog restriction that says no service name to B, and service B won't show up to any of the users that have access to the services from that broker. Similarly, you can specify a whitelist. Give me only service A when you create the broker, so only A will show up to users on the system. And combined, these two features pretty much allow a great deal of permutations of access control. So if you have a broker, you only want to specify those resources to specific users, or even specific resources on that broker to specific resources differently. These two combined will allow you to do that. SVCat. So this is the other big thing we've been working on in the past 6 months. We've been implementing our own custom CLI for several reasons. One, I mentioned earlier, the naming sort of weirdness, the collision between how Kubernetes treats names and OSB resources have names, make it kind of confusing to reconcile those two. So we created our own CLI and generally refer to Service Catalog resources only via their external name, which is usually something that's human readable. MySQL databases, 100 megabyte MySQL databases, rather than GUID, which is AXB underscore MySQL 1234. So we allow that to be easier for the user to provision, browse, use resources that's easier for them. Additionally, we sort of want to follow a more imperative model of resource interaction because we have to go out and call out to this external platform. Unexpected things can happen when the users directly manipulate the Kubernetes resources, and this sort of lets us pull that under the covers and away from the user's hands to sort of hide that from them. Additionally, we have a couple sort of niche features that aren't really representable directly in normal Kubernetes abstractions. The classic example we like to use is the marketplace command that we have implemented, which is show me all of the services I can buy using Service Catalog, which is represented by multiple resource types amalgamated together. For instance, show me all the classes of services available to me and all of the plans that are attached to those, which you couldn't get if you were just like, show me all the classes available in my cluster to me. Future plans. So this is what we're hoping to do in the next 6 months. We are still a beta project. We are coming up on 1.0, but that's still sort of under contention for what exactly that's going to mean. But this is just a quick list of the things we're actively working on. We're investigating the use of CRDs to replace our own custom API server. This is still up in the air whether all of the functionality that we currently have can be replicated using CRDs. It's looking somewhat hopeful, but we haven't gotten around to actually implementing that yet. Like I said, the ongoing synchronization between Kubernetes and the brokers, the synchronization of the resources and state, that's an ongoing sort of fight that we work on. Default parameters to allow for operated creation of custom classes and plans. So currently, all of the classes and plans you will see on a cluster come directly from the catalog offered by the broker. We're creating the feature to allow cluster operators to create custom classes and plans and pre-specify parameters such that, like, if it's a configurable size, you provide a parameter that says how big my database is going to be. We would allow a cluster operator to pre-specify that so the user wouldn't have to care. They could just be like, pick from a list that doesn't necessarily exist on the broker itself. Pod presets. So currently, when you create a binding, the output of creating that binding is a Kubernetes secret created somewhere. It is not automatically connected to your application. And we want to take this a step further so that the user doesn't have to go and manually add that to their pod declaration or deployment declaration. The problem with that is this is not really accomplishable from our little extension project. We need to implement actual functionality inside the mainline Kubernetes repository. So we're currently collaborating with some of the core teams to get this done. But like I said, it's a project in motion. And then, reiterate again, we're coming up on our 1.0 release. So that hopefully should be sometime in the next 6 months. We should graduate. Okay. So that's pretty much all the material I have prepared. I can field questions now, but before that, just a quick rundown of some resources. So this first link here is our general documentation. What is Service Catalog? How do I start it? How do I use it? How do I get up and running? This is our actual repository. If you're interested in contributing or just checking out what issues we're working on at any given time, that's a place to check that out. Open Service Broker API, this is a link to the specification of the API itself, which, like I said, is also currently under active development, both in support of features we need and other platforms need. And if anyone here is interested in contributing, for the next several weeks, we are going to try and have some of our SIG meetings rescheduled to a China-friendly time. So I believe the first one is next Monday here at 9 a.m. And that's the link to join that if you're interested in talking with us, helping contribute. If you have any problems, please feel free to show up and voice your concerns. So that is all I have. Does anybody have any questions?
For the catalog restrictions, did you say that that's per user, like RBAC? How does that work?
Okay, so no, that's not based per user. The way that works, so this happens when you create a service broker. So when you kubectl create service broker, you can pass it, one of the fields in the spec is a catalog restriction, which is like only service, or what this one's, no service B. So don't give me any services named B. So whoever does this is whoever has permissions to create service brokers on the cluster. So for a cluster service broker, usually an admin. And then this will be for anyone who's capable of viewing services from the service broker. They won't see service B. It's like it doesn't exist. So this isn't RBAC, not exactly. Does that answer your question? Yeah. Yeah. Okay, anyone else?
Hi, so for the catalog restriction feature, can you add the feature into some operations for the service instance, such as the system will restrict the user not to update or not to delete it?
No, not at this time. So we don't have the capability to do that right now in catalog restrictions. Like I said, it's sort of an ongoing problem because some brokers do enforce restrictions like that, like you can't delete a service after 5 o'clock. And we currently don't have any way to represent that range of restrictions inside of our resource model. So no, you can't do that right now, but we are working on letting you do things like that.
Okay, so the next question is for these two features you mentioned. Will they have some impact on the open source broker API? If so, which place would you want to update in the profile or in the specification itself? So, like I said, currently OSP is also under ongoing development. And this isn't a problem just for us. Other platforms that implement the OSP API have similar issues. And we're currently we're just getting started on version 3 of OSP API, so we're starting potentially a new, entirely different API from scratch. So the answer is probably going to be both. The specification itself will probably change some to allow for the additional hooks and endpoints we need to be able to manage things like this. And then it's also, we're going to have to go and then make changes based on those in Service Catalog itself. Anyone else? Okay, thank you for being here.